How memory works, from bits to RAM and beyond. Chapter 1 Introduction. What happens when you open a browser? Launch a game? Watch a YouTube video? Where does all of that information live while the computer is running? The answer is memory. Memory is one of the most important components in every computer system. Without memory, the CPU would have nothing to process. Programs could not run. Data could not be stored. And modern computing would be impossible. In this video, we will explore how memory works from the transistor level all the way up to modern RAM. Chapter 2 What is memory? Memory is a place where information is temporarily stored. Think of memory as a workspace. The CPU performs calculations. Memory stores the information needed for those calculations. Without memory, the CPU would constantly forget everything. Memory allows programs and data to remain available while the computer is running. Chapter 3 Everything starts with bits. All memory stores bits. A bit has only two possible values, 0, 1. These values represent electrical states. Voltage off. Voltage on. Everything inside a computer eventually becomes a collection of bits. Numbers. Letters. Images. Videos. Programs. Everything. Chapter 4 Bits become bytes. Bits alone are not very useful. Computers group bits together. 8 bits form 1 byte. 01000001. This byte represents the letter A. A few bytes can store a word. Millions of bytes can store an image. Billions of bytes can store an operating system. Memory stores all of these bytes. Chapter 5 The memory cell. A memory chip contains billions of tiny storage locations. Each location is called a memory cell. A memory cell stores 1 bit. 0. Or 1. Think of each memory cell as a tiny electronic box. The box can hold either an OFF state or an ON state. Billions of these boxes form modern memory chips. Chapter 6 Memory is built from transistors. Memory cells are built using transistors. A transistor is an electronic switch. Millions and billions of transistors are connected together to create memory hardware. Just as transistors create logic gates inside a CPU, they also create storage cells inside memory chips. At the lowest level, memory is simply a gigantic collection of transistor-based storage circuits. Chapter 7 What is RAM? The most important memory in a computer is RAM. RAM stands for Random Access Memory. RAM acts as the computer's working area. Programs running right now are stored in RAM. Data currently being used is stored in RAM. The CPU constantly reads from RAM and writes to RAM. Without RAM, modern software could not run efficiently. Chapter 8 Why is it called random access memory? The word random does not mean unpredictable. It means any location can be accessed directly. Imagine a bookshelf with 1 million books. If you want book number 500,000, you can go directly to it. You do not need to read all previous books first. RAM works the same way. Any memory location can be accessed immediately. This makes RAM extremely efficient. Chapter 9 Memory addresses. How does the CPU find a specific piece of information among billions of memory cells? The answer is addresses. Every memory location has an address. Think of memory addresses as house numbers. Address 1000. Address 1001. Address 1002. Address 1003. The CPU can request, read from address 1002. Write to address 1003. Addresses allow computers to organize enormous amounts of information. Chapter 10 Reading data from memory. Suppose the CPU needs a number stored at address 1000. The CPU sends the address. The memory hardware locates the correct cell. The stored value is retrieved. The value is sent back to the CPU. This process happens billions of times every second. Every application depends on memory reads. Chapter 11 Writing data to memory. Writing works in the opposite direction. Suppose the CPU calculates 5 plus 7 is equal to 12. The result must be stored. The CPU sends address and data. The memory hardware updates that location. Now the value 12 is stored in memory. Every save operation, every mouse click, every game action eventually becomes a memory write. Chapter 12 Volatile and Non-Volatile Memory. RAM is volatile memory. When power disappears, data disappears. Turn off the computer. Everything stored in RAM vanishes. Storage devices work differently. SSDs and hard drives are non-volatile. They keep data even when power is removed. Think of RAM as a whiteboard. Think of an SSD as a notebook. One is temporary. One is permanent. Modern computers need both. Chapter 13 Why more RAM improves performance. People often ask, why does adding RAM make a computer faster? The answer is simple. More RAM means more data can remain in fast memory. When RAM becomes full, the operating system must move data between RAM and storage. Storage is much slower. Imagine working at a large desk. Everything is within reach. Now imagine working on a tiny desk. You constantly move papers back and forth. That extra movement slows everything down. RAM works exactly the same way. Chapter 14 The Memory Hierarchy. Not all memory is equally fast. Modern computers use multiple layers of storage. CPU registers, CPU cache, RAM, SSD, hard drive. As we move downward, capacity increases. Cost decreases. Speed decreases. The closer memory is to the CPU, the faster it becomes. This structure is called the memory hierarchy. It is one of the most important ideas in computer architecture. Chapter 15 RAM is not the fastest memory at this point. You might think RAM is the fastest memory in a computer. Surprisingly, it is not. Modern CPUs contain tiny storage locations directly inside the processor. These storage locations are called registers. When the CPU performs calculations, it rarely works directly on RAM. Instead, RAM register ALU data is loaded from RAM into registers. The CPU performs calculations using registers. The results may then be written back to memory. Because registers are located inside the CPU itself, they are dramatically faster than RAM. In fact, registers are the fastest memory in an entire computer. In our next video, we will open up the CPU and discover how registers work. Conclusion: memory is the workspace of every computer. Bits form bytes. Bytes form data. Memory cells store those bits using transistors. Billions of memory cells form RAM chips. Every application depends on memory. Every operating system depends on memory. Every CPU constantly reads and writes memory. But RAM is only one layer of a much larger system. Modern computers use a hierarchy of storage technologies ranging from hard drives all the way up to ultra-fast CPU registers. And those tiny registers are where our journey continues next video, how registers work, the fastest memory inside the CPU.